Okay, we're waiting for the level of number of participants to stop increasing. All right, why don't I start? So welcome to the first lecture of the BRED IGC lectures on economic development. The first module, as you know, is devoted to education. And you'll note that we didn't call it schooling because, of course, education is not necessarily equal to the number of schooling years. Although in the lectures I'm going to give, when we look at empirical work, we're mostly going to look at years of schooling, which is, of course, an important determinant of education. The way I'm going to run the lectures, we do want to give people the opportunity to ask questions. And the way we're going to do it is you can pose your questions in the Q&A box. And in the last 10 minutes, a representative of IGC will convey those questions to me and I'll try to answer them. We have 2 lectures. I'll be lecturing tomorrow as well. So if I don't get a chance to answer all the questions in those 10 minutes, we will have time tomorrow as well to answer them. Okay, so we're going to have many lectures on schools producing education, but my lectures are going to concentrate mostly on the productivity of schooling and on the determinants of people's demand for schooling. So we're going to look at the productivity of education with schooling years as a proxy. And of course, a key question is going to be how we measure productivity. And once we do that, what determines variation in productivity? And then some of the barriers that we're going to look at in particular will be a barrier to school enrollments are going to be low productivity, that people may not be acquiring schooling simply because they perceive, perhaps correctly, that in their environment, productivity is low. And so we want to understand what productivity is of schooling. And then we'll look at some other barriers like income, health, and family size as well, focusing on those things tomorrow. So let me start with some facts about schooling. The first is, you know, low schooling is a major feature of low-income countries. There's a strong positive correlation between schooling and per capita GDP. And so it naturally leads to the question of whether low schooling is the cause of underdevelopment or whether underdevelopment itself causes low schooling. Is this just an income effect? Is it in fact low productivity? Is it that in low income environments, the schools are pretty bad. They don't produce much learning, and so people stay away from them. And I'll also show you something that surprises most people, which is that in most countries of the world, including low-income countries, the schooling of women actually exceeds that of men. And one of the issues that we'll look at is why that's true. So here's an example of a number of countries. This is from World Bank data, which shows the fraction of 15 to 19-year-olds who've completed just 9 years of schooling. And you can see it varies a lot, and it's far from the mostly 100% that we would see in developed countries. So, you know, this is an issue. And if we look at the correlation of taking the same countries and correlating them with their GDP per capita in PPP terms, we see there's a very clear positive correlation with GDP per capita. And you might think maybe I cherry picked those countries. I did pick them based on the recency of the data and the fact that they're sort of representative of areas. But if we include all of them, then the correlation, you know, looks pretty much the same. The second fact is, when we break it up by male and female, we can see that in all of these countries, almost all of these countries, the schooling attainment with this measure and most other measures is greater for females than males. There are exceptions. India is an exception, and Pakistan is an exception. So you might think maybe it's religion, but if we look at Bangladesh, there's more female schooling than male schooling in the current period. So it's mostly that women are getting more schooling than men, even in environments where there's clear evidence of male bias. And we'll look at that as well. All right, so the first thing I want to discuss is the productivity of schooling. And most people will focus on the rate of return to schooling and think that the rate of return to schooling is what you need to know to understand the productivity of schooling. So for example, if we were allocating rupees or dollars across different investment opportunities or even across countries, we would clearly look at the rate of return to dollars or rupees. And those would be informative about where those dollars would have the major impact. That does not carry over to the rate of return to schooling, which is what I'm going to show you. So if that's not the case, then what do we need to know about how do we measure the productivity of schooling? What determines it? And we're going to look at the issue, at least theoretically, of why schooling could be a factor in increasing economic growth. All right, so let's start with that. So the major ideas for the role of schooling and health, for that matter, in fostering growth is the following. So in exogenous growth models, where growth is solely determined by technological change, what's hypothesized is that what's going to matter across countries is how rapidly the countries adopt new technologies, which will facilitate growth. And there, in fact, is a role for schooling, which is hypothesized by Nelson and Phelps, that schooling might facilitate technology adoption. So we want to look at that. And we also want to understand why that should be true. In endogenous growth models of Romer and also of Lucas, learning externalities plays a major role. And so the natural questions would be, is there learning from others? And does schooling facilitate learning? So we want to look at that as microeconomists. And Lucas has the idea also that human capital makes more efficient the production of human capital. We're not going to look so much at that in the lecture. These lectures are an abridged version of the lectures I give in my course at Yale. So I'm picking what I think are the highlights of that. So the question is schooling always productive, which is what's assumed in these models? And is it true that a higher level of schooling actually facilitates production of schooling, which I said I'm not going to look at, but there are lots of studies of that, both from high income and low income countries. All right, so let's start with micro studies of schooling returns. And let me start with two caveats about that. So the most common way that people estimate the rate of return to schooling is regress the log of wages on years of schooling, which we'll talk about in a second. The problems with that, for doing it for low-income countries, is that in fact most workers don't work for wages. So you see some statistics there. 45% in 1999 of activities of men in prime age group are not in wage or salary work, and it was even higher when we go back in time, and now it may be 38% or something like that. And secondly, we always have this issue that wages may not reflect productivity, and in many countries of the world, the government is a major employer of highly educated workers, and it's pretty clear that the wages set by government may have little to do with market productivity or opportunity costs, because we see large amounts of unemployment associated with people queuing up for these jobs, which may suggest that the wages are higher than the market equilibrium. But let's, for the moment, ignore that issue and look at this earnings equation that people have been estimating. There must be thousands of estimates of rates of return to schooling based on the Mincer earnings equation, which is set out there, which has the log of schooling as a function of linear years of schooling and experience. So the question is, first, what determines beta? And in order to understand this equation, we need to understand where it comes from. And there is actually a model. The reason it's named after Mincer, Jacob Mincer, is that he actually formulated a model which generates the specification. So here's what the model is, and you can see how strong the assumptions are to get this functional form. It's based on the arbitrage model of Adam Smith, and it assumes that people will time discount. So if we define lifetime income, the discounted present value of lifetime income, for an infinitely lived agent, you see it's just going to be the integral from the year in which the person who has amount of schooling S enters the labor market over the wages that are accumulated over that time, okay, that are discounted, where the exponential is the discount rate R. Okay. Right. So this assumes that people are full-time in school, so they're not earning anything while they're in school. And the infinite life assumption is actually innocuous, because you can do this for 40 years and you'll get the same result. The economics of this is that there's no barriers to schooling in the economy. So in equilibrium, the discounted present value of lifetime earnings is going to be the same for everyone, regardless of how much schooling they get. And the way it works is the following. Suppose that for some reason in the economy, going to college gives you a lot more earnings than going to primary school. Okay, that it suddenly becomes much more productive in the economy, whether it's due to technical change or whatever reason. What will happen in this model is that more people then will shift to getting a college education. There's no barriers to that, which will, in equilibrium, general equilibrium, lower the wage from going to college. And in the final equilibrium, again, the lifetime earnings will be, discounted lifetime earnings will be the same for everyone. So it doesn't matter what the differential productivities of different levels of schooling are, lifetime earnings will be the same. And under these assumptions, you get the log earnings equation of Mincer, and only under these assumptions. All right, so let's stick to that equation. Let's just say it's a pretty good approximation. It's obviously not fully descriptive of what goes on. All right, so, and then we can ask, what's most important in accounting for differences in the productivity of schooling across countries? So the marginal product of a worker is, we just take the derivative of output with respect to adding a worker. That's equal to the wage. And using the Mincer specification, then that's going to be the wage for someone with no schooling times the exponential of beta, the returns to schooling. Okay. So then we ask, all right, suppose we increment schooling by 1 year. We take the derivative of the marginal product in the last equation, and we get the formula for the contributions of schooling to the marginal product or marginal productivity of workers. So you see that it contains both the rate of return to schooling and the base wage, the wage of the lowest schooled person in the economy. And so then the question is, what's most important in determining the variation in this across countries? Is it the base wage or is it the rate of return to schooling? Okay. Well, there's been a compilation of the rates of return to schooling across different countries of the world. This is a classic source that's used in many macro studies. Okay. And these are the numbers. And you can look at these and you can see, if you can see, that these rates of return, which are in the third column of numbers, they don't vary very much. They go from 3.6% to maybe 15%. That's the kind of range. But they don't seem to have any major relationship to the average incomes of economies. So the rate of return to India is 6%. The rate of return in the US, according to this, is 9%. But Mexico, it's 14%. So it's just not clear what these numbers are telling us. But the key thing is that the span of these differences is quite small. Okay. What about the base wage? Well, the World Bank has also put together sort of the wages that people are earning in the economies. And you can see that, for example, 44% of workers earn less than $5.50 per day. And if we compare this, for example, to the minimum wage in the United States, which is $120 per day, if it were $15, and of course that's higher than it might be in many states. But let's take that as our standard. You can see that for 44% of the world's workers, they're earning much less than 120 per day. These are the lowest wages that people will earn. And so the variation in base wages is much greater than the variation in the rate of return to schooling. But we can estimate that directly. So I prefer an approach that is choose the MincerSmith model, okay, and just makes it very simple, which is that the wage a worker commands in the labor market is going to be equal to the number of skill units that the person brings to the labor market times what the rental price per unit of skill is, which is in this case, omega. That's the skill price. And we can think of workers around the world with a similar level of X, okay, and the omega J varies across the different countries. And what we want to understand is and estimate what those omegas are across countries. Now we can have different types of skill and different skill prices for different types of skill. It's not going to change the basic formulation. Okay. And we can think that skill is produced from schooling, years of schooling and other inputs. This is where the schooling production functions come in that will be the focus of this module for the later lectures. So for example, if we posit that there's an exponential function for years of schooling and other inputs, we can allow for skill endowments to vary and be unobservable. Okay, we put this into the equation, take logs, and we get an equation that looks similar to the Mincer equation, but the intercepts are the log of the skill prices. So what we'd like to do is estimate this equation across different countries of the world, allow the betas to vary across countries, so that's why beta has a J subscript, and allow the skill prices to vary across countries. Okay, and the variation in the intercepts are going to tell us what the base wages are. And if we know the beta and we know the base wage, we can compute what earnings would be for any different skill level or every different schooling level. Okay. Now there are data that provides for us the earnings of people in many countries of the world obtained from a consistent survey regime or survey instrument. Okay. And the one that I'm going to show you results from is the new Immigrant Survey, which is a survey of immigrants to the United States in 2003. It's a representative sample of them. But the key point of this is that it obtained information on the last earnings of those immigrants in their home country, along with information on their worker experience, et cetera, in those countries. And it provides us for 140 different countries the earnings and schooling of workers from a common questionnaire. So with that, we can estimate the betas across these 140 countries and the intercepts. And we can even allow schooling years to be modified by measures of quality of schooling, but we'll ignore that here. Okay. So this is what running a regression of log of wage across with fixed effects for countries, which are going to capture, of course, the base wages, has 3,400 workers, 131 sending countries that have complete information. The average rate of return in those home countries is 10%. But what's most important is that the skill prices, the intercepts, differ significantly across the countries, but the rates of return to schooling, you cannot reject the hypothesis that they're basically the same. Okay. So what do those skill prices look like? Okay. This is a graph for 19 Asian countries, obtained from actually two different data sets, but they basically say the same thing. The OWW is the occupational wages around the world, which is based on ILO compilations of earnings by occupation. You can still do fixed effects in an occupation earnings equation. And so these are from the fixed effects. And they spit out results that are what you would expect, that the price of skill in Taiwan and Singapore, these are again only Asian countries that are represented here, Hong Kong, are much higher than they are in India, Cambodia, Laos, and Mongolia. Fine. All right. So now, given the knowledge of the skill price and given the rate of return, we can actually then estimate what earnings would be for any given schooling level. And let me show you what that looks like. So here's a set of countries: Nigeria, India, Indonesia, Mexico, and Korea, using the estimated skill prices and just arbitrarily setting the rate of return to schooling at 7%. You can see what the earnings are of high school and college graduates in a different set of countries in the world. And what's apparent from this is that the increment in earnings from going from being a high school graduate to being a college graduate differs enormously across countries, that the productivity of additional years of schooling differs substantially across these countries. Okay. And one could look at this and say that everything else the same, if we gave everyone in the world a college education, it would have very little impact on the inequality in income per capita across the world. And that's even ignoring the general equilibrium depressing effect of what would happen if we augmented schooling by such an enormous amount in many countries of the world. So it's pretty clear that the job of development economists is to understand the differences in the productivity of schooling across these countries, and that the simple notion that if we could only increase schooling in low-income countries, that would automatically generate higher productivity is not so obvious. So we need to understand that variation in the skill price or the rewards to or the productivity of schooling across countries. Okay, but by the way, just to show you that if you alter the rate of return in one country versus another, say Mexico and the United States, it just has tiny impact on the differences in wages or the returns, the productivity differences by schooling level. All right, so we're now going to engage in the issue of what determines the productivity of schooling, given we see this enormous variation. Now, one caveat, of course, that I've mentioned is this is all based on wages. So we do have to worry that even these estimates may not be quite right. And we'd like to measure productivity directly. And so what we're going to do is we're going to focus on the agricultural sector. And there's three reasons for this. The first is that the measurement issues are much less problematical. We can measure output directly. We can measure profits directly. The technology of production in agriculture is relatively transparent compared to other occupation industries. Suppose, for example, we wanted to understand whether a PhD in economics from MIT was more productive than a PhD in economics from, say, Columbia. And we ignore the selectivity of those two institutions. We'd immediately face the issue of, well, how are we going to measure productivity? Is it going to be number of articles that people write? Is it going to be articles in top 5 journals? Is it going to be the citations of those articles? What about teaching productivity, which is part of the occupation of people with PhDs? How are we going to do that? When should we measure that? At the end of life, after 10 years, after 5 years? Lots of questions, no obvious answers. For agriculture, it's how much output you've produced and the value of that output. And we can also measure the inputs pretty straightforwardly. So the second reason to focus on the agricultural sector is that the data are much richer. There's detailed information in many data sets on the inputs that are used, the characteristics of those inputs, as opposed to firms in most countries. I mean, the best firm data has information on number of workers and capital as some aggregate financial amount. It might have differential schooling of the labor force, but that's pretty rare. But for agriculture, we're going to have a lot of information. And the third reason for focusing on the agricultural sector is development economists. We want to focus our attention, not that we can't learn from other countries, but on low-income countries. And the main occupation of workers in low-income countries is in fact agriculture. So 42% of the labor force in India, 30% still in China, 61% in Kenya of the labor force is engaged in the agricultural occupation. So understanding productivity there is going to tell us a lot about productivity in those economies in general. All right, so we're going to ask, does more schooling raise farm productivity, or when does it? So one approach that we see in the literature is to estimate the production function. So Q is output, F is the production function that has as inputs here labor, variable inputs like fertilizer, and of course land. And then there's the total factor productivity parameter theta. And we could hypothesize, as is done in the literature, that theta, total factor productivity, might be a function of schooling. Now, suppose we could estimate that. The question is, what does that tell us about the productivity of schooling? Well, specifically, it says how total output varies by schooling, holding constant all the inputs. So it says that two farmers who have exactly the same land size, the same quality of land, who use exactly the same amount of labor, exactly the same amount of fertilizer, and all other inputs, for some reason, the more educated farmer has more output than the less educated farmer. That seems a little bit peculiar, and it's not obvious what is going on in that. And therefore, one might ask, holding constant all inputs seems kind of peculiar, because it would seem that the major challenge in agriculture is deciding on the allocation of those inputs. And maybe schooling has a role to play there. So an alternative approach, a better approach in my mind, is to estimate a profit function. And here we've simplified where there's just one variable input. So the profit function comes from the maximization problem where the farmer is maximizing profits, allocating inputs appropriately. There still can be a total factor productivity theta in this problem. And the first order conditions are well known that the farmer should be allocating inputs such that the marginal value product of the input is equal to its price. Okay. So we could presuppose that schooling contributes to the farmer making better choices, to coming closer to the first order necessary condition for profit maximization or cost minimization. And so then the full marginal contribution of schooling then is the effect of schooling on the allocation of the input times the net contribution of the input to profits. Okay, and possibly then there's also an effect on total factor productivity. So for example, if the farmers in general are using too little of the input, then the value of what's in parentheses, if they're using too little, should be positive, right? Then if schooling in fact increases the use of the input, then it'll have a positive return. And similarly, if they're using too much, so this is negative, then if schooling pushes farmers to use less of that input, then again, this will be negative and this will be negative, we'll get a positive contribution. So this first term is the allocative effect of schooling. Okay? And so we obtain the total contribution of schooling from estimating the profit function. That will include its effect on TFE, and it will include any allocative effect. So the next obvious question is, under what circumstances is the allocative effect going to be most important? And we can hypothesize that one environment where that's true is where there's new technologies coming in. So we'll examine that as well. But first, let's look at the low base case, okay? Suppose that we have workers who are harvest workers. We can measure their output very easily. We can just weigh the amount that they harvest, okay? And we can compare the amount that they harvest across workers by their characteristics, including schooling. So this was done for Filipino harvest workers. This is from a simple regression of the piece rate wage that they earned. Everyone was, the amount per pound that they were paid was the same for every worker. So variation is only based on their productivity, the amount that they harvested. And on the right-hand side, it has age squared, the height of the worker, and their schooling. And these are the graph shows the partial effects. And you can see that schooling has very little impact on the productivity directly measured of these workers. Height has a much steeper slope, has a much bigger effect. Now, this is not surprising to us, but what it tells us is if we have an economy where most of the workers are engaged in harvest work, then the returns to schooling in terms of augmenting productivity is going to be relatively low. So the environment, the technology, the kinds of work that people do are going to importantly affect the productivity of schooling. All right, so let's take some more dynamic effects. So we're going to look at two. We're going to look at two technological revolutions. The first is the contraceptive revolution, and the second is the green revolution, which is, of course, much more relevant to studying development economics, given its agriculture. So the contraceptive revolution was, like the green revolution, we can date its inception. That is, new contraceptive devices were introduced for the first time in the mid-1960s. And we have a good data set that's going to tell us about the effectiveness of the use of these new technologies by women with different levels of schooling. Okay, so we can actually look at the use effectiveness of these new technologies compared to an old technology by schooling level. And this is what you get from the data. All right, so the pill and IUD are the new technologies. And use effectiveness is, these are people using the technology, saying they're using these contraceptive devices and looking at the actual number of pregnancies that occur. So the actual effectiveness, and you can see there's absolutely no difference between high school graduate women, married women, and college graduate women. Okay, fine. But when we look, we can contrast that with the traditional technology, which is the rhythm method. And what we see is there's a massive difference in the use effectiveness of the old technology versus the new technology. So what does this tell us? Well, it tells us that it's not the novelty of the technology. For these women in 1967 and 65, these were clearly new technologies, but it's about complexity. There's nothing very complex about using the contraceptive pill. You take the pill in those years every day. They're usually given in a box that has the daily pill illustrated. Now, IUD is inserted by a doctor. How could there be any reason for schooling to have an effect? The rhythm method is much more complicated. It requires keeping track of time, a basic understanding of biology, etc. And it turns out that there's a big difference in the schooling effectiveness, the productivity of schooling in the enterprise of prohibiting births. All right. So what about the Green Revolution? So the questions we want to ask here is the Green Revolution, which I'll describe in a little more detail in a moment, which was a new flow of challenging new technologies, new seeds that were very different in their character than traditional seeds. Did it increase the return to schooling? Which level of schooling? For whom did it increase the schooling returns? And then we're going to ask, if it did, do we see a response of schooling investment to the changes in the productivity of schooling? And if so, by whom? All right, so what are the features of the Green Revolution, at least in the initial stages, and looking at India? So some nice features for identifying impacts. And the first is that the innovation in seeds occurred outside of India. So the high yielding varieties of hybrid wheat, rice, and corn were developed not in India. So wheat was developed in Mexico. Norman Borlaug won the Peace Prize for being a leader in that enterprise. The rice varieties were developed in the Philippines at the International Rice Research Institute, IRRI, there. Okay. Now, India welcomed these new varieties and in fact followed them up with substantial public investment in improving them for local conditions. They subsidized fertilizer in areas where they thought these crops could be most productive. They even supplied subsidized credit in these sort of areas that they predicted would benefit most from these varieties. Now, it's important to note that unlike the pill and IUD, where they appear and then they're there for perpetuity, the Green Revolution is different because it's not that suddenly there was a new seed, but from then on, there was a continuous development of new seed varieties. So every year, farmers have to choose whether they should use the new seeds, the newest seeds, or stick with the seeds that they know, which may also be high-yielding varieties, but not the newest high-yielding varieties. So there's a continuation of challenges every year. And the challenges are whether to adopt these new seeds and also how to use them. And the optimal use of the seeds was a difficult task because, in fact, the high-yielding variety seeds were much more sensitive to water and to fertilizer than the traditional seed varieties. And one consequence of that, and this is what the Indian government actually recognized, was that the HYV seeds were only going to be suitable for particular regions because it required particular amounts of sustained rainfall and particular soil properties as well. This is going to help us understand the consequences of technology for schooling returns, this variation that is fundamentally exogenous. All right, so what about the challenges? So this is the information at best that farmers were provided. Okay? This is information that was obtained from experiments on plots. Okay, so there were indeed RCTs relevant for development in 1988, right? A long time before RCTs became popular in development economics. And in fact, RCTs have been going on in agriculture since the early parts of the 20th century. In any case, what these graphs are showing us is a couple of things. The first is that the high-yielding varieties have Spanish names. This is for wheat, so these are Mexican varieties. The traditional varieties have Indian names. UP is Uttar Pradesh, the state, okay? And we can see that the high-yielding varieties for every level of fertilizer, the x-axis, indeed have high yielding. They're much higher yielding, okay? But they also show us that the sensitivity of the yields to the amount of fertilizer is much greater for the high-yielding varieties. The consequences of getting it wrong are much bigger for the high-yielding varieties than they are for the traditional varieties. So the challenge for farmers is which of these varieties should they choose and how much inputs they should use. Yeah. So we're going to look at the experience of the farmers at the onset of the Green Revolution, because at that time, there was an incredible data set that was collected that began in 1968 and was a continuing 3-year panel for over 4,000 rural households in 250 villages spread across the 17 major states of India, meant to be representative of the full population, rural population of India. It's a representative sample. You use the weights, okay? So we have a 3-year panel right at the start of the Green Revolution. And then there were follow-up panels in subsequent years. We're going to look at that 3-year panel intensively because that's when the new technologies were indeed new and novel. And then we'll look at a follow-up for the second round to understand what happened to the returns to schooling. This is a map of where the villages are. You can see that they're spread all over India, and that spread across India is going to help us a lot because there's exogenous variation in the potential of these new high-yielding varieties to increase output. All right. So the first thing you see, if you look at the third round of that initial data, just descriptively, is that it was for given farm size and the various services that were provided in the villages, you find that indeed the primary school farmers were much more likely to adopt the new high-yielding varieties by the 3rd year of the panel. Okay, now that doesn't tell us very much because it could be that in areas where the seeds were much more productive happened to be areas where people had a lot of schooling. Right? It's cross-sectional, but it's a hint that schooling seems to matter, but we want to understand more than that and why. Okay, so what we can do is we can take advantage of the panel, and we can, just like in the contraceptive study, look at the use effectiveness of actually using the high-yielding varieties. Okay, so we're going to these estimates are fixed effects farmer, and identification comes from the change in the use of high-yielding varieties over time for the farmer. Okay, and it takes into account that, of course, the use of high-yielding varieties is endogenous, so there are instruments for that, which are basically the initial values of the assets and wealth of the farmers' initial period. So it takes into account that indeed there are constraints on the adoption of new high-yielding varieties associated with the credit market and with liquidity. Okay? And what you can see is that on average, these are t-values in parentheses, on average, the contribution of using high-yielding varieties to farm profits was 0 in those initial years. So what's going on? Well, if we break it down, we look at the effects of the high-yielding varieties by farmers of different characteristics, by their schooling, and by the proportion of the land irrigated. We get a better understanding of what's going on. What we see is that for farmers that were illiterate and had no ability to control water, the average return to the use of these high-yielding varieties was in fact significantly negative. Okay? However, if they had more schooling and they had irrigation, they would get positive returns. So it really mattered. This is farmer fixed effects. So this is not capturing differences across areas in the productivity of high-yielding varieties, but mainly the characteristics. So this gives us a hint that schooling is enabling farmers to get more out of the new technology. But the question is, why is that? What is going on? Why is schooling enabling farmers to be more productive with this new technology? We can have 2 hypotheses. The first is that, say, the literate farmers were better at reading those graphs that I showed you, or they could read the instructions, or they could read the labels on the bottles that contained the seeds. So that's one. But the second is that more schooled farmers were better able to learn from their experience of using the high yielding varieties, that the learning by doing returns were higher for the more schooled. The question is whether we're able to do that, whether we can actually test the learning contribution of schooling. And to do that, we need to posit a model in which we embed the adoption of new technologies or the use of the inputs for those new technologies with schooling. Okay, so let's do that. So this is a model, the target input model. That's by the wrong year. It's 1996, not 86. We're not quite that old. So this is a model of using the new technology. And it's a model in the literature, the target input model, that's modified to be relevant to the issue of adopting a technology in agriculture. Right? It's really straightforward. So ADA is the frontier profits, the profits that you could get from the new technology if you do everything right. Okay. And the term in parentheses, theta is the input that farmer J uses at time period T, say fertilizer, the amount of fertilizer used, theta. Okay. And theta JT superscript O is the stochastic optimal amount of fertilizer the farmer should have used. Okay. And if the farmer actual use of fertilizer differs from the optimal amount, there's a penalty. The profits are lower. So that's straightforward. Okay. Now, the optimal input use in agriculture is stochastic. The optimal input use of, say, fertilizer, or even the amount of seeds, or their spacing of seeds, is going to depend on what occurs subsequently, rainfall, for example. So the amount of fertilizer used, optimal amount of fertilizer used, depends stochastically on on rainfall, for example. So if we assume that the optimal input level, which varies over time, has a distribution that's normally distributed with the mean theta star and some variance sigma squared mu, okay? And we assume that farmers have some prior over that mean theta star, and that prior is also normally distributed. The prior can change over time, and there's a variance in that prior, the posterior variance, which will specify a sigma squared theta JT. Okay. Now notice that in the absence of predictions about the realization of states of nature, the best the farmer could do is choose a theta JT, which is the mean of the distribution. That's the best they can do in terms of maximizing expected profits. So the challenge is for the farmer to figure out what the mean of the distribution of the stochastic input fertilizer should be. Okay. So given these normality assumptions, you get that expected profits then is going to be a function of the variances in the posterior prior and the variance in the stochastic input itself. And intuitively, you can see this makes sense. If there's a lot more variability in the optimal input, then profits on average are going to be lower. And if the farmer is much less sure about what the optimal input should be, then farmers are going to, the expected profits are going to be lower. Okay? Now, if we assume then Bayesian learning, then Bayesian updating implies that the variance of the posterior is going to be equal to 1 over the precision of the initial prior and the precision of the posterior times the number of trials using that technology. We can think of it as the number of years of experience with the new varieties. So rho 0 is 1 over the variance of the initial prior. So it tells us that there was a lot of uncertainty initially, then the posterior is going to be lower as well for any given experience, which means that expected profits are going to be lower. But it also tells us that if rho, the greater is rho, the greater the the learning is from different trials with the high yielding variety. And intuitively, it makes sense that you're going to learn less the more variable the optimal input is, right? Because there's a lot of noise. Basically, the signal noise ratio is lower. Okay. So the implications of this is, one, profits in any period are going to depend on cumulated experience. So that specification I showed you a few minutes ago is actually incorrect because it doesn't take into account experience. It takes into account schooling, it takes into account irrigation, but it doesn't take into account that over time, farmers have different amounts of experience with the high yielding varieties. The second implication of Bayesian learning is that profits will rise at a diminishing rate. So this is important for identifying this type of learning from other types. Okay? And it's pretty clear that the returns to learning are going to depend on the scale of operation as well. And so right away, we see that farmers with a larger scale of operation are going to have a higher return to learning than farmers with a lower scale. All right. So now we're going to introduce schooling into the model. And we'll assume that schooling affects the two types of precision, that the initial precision is going to be a positive function of schooling, and the degree to which the farmer learns from experience is also going to be a positive function of schooling. That's the learning component. Okay. So if we take the derivative of expected profits from the model's equation that embeds in it the learning, we get this expression, which clearly tells us that schooling, denoted by E here, will have a positive effect on profits if there's any contribution of schooling either to learning or to having an initial information advantage, that they were able to decode the written information or the graphs. The issue is, can we identify the learning effect from experience? So if we take the derivative of this expression with respect to years of experience with a high yielding variety, we get the following expression. And it's clear that the following: if there's no learning, but only an initial advantage, then over time, as the farmers learn about the new technology, the differential in profits between the schooled farmers and the unschooled farmers will shrink over time. On the other hand, if there's not an initial advantage in schooling, but rather that the more skilled farmers are better at learning from the new technologies, then what we should see is the effect of experience on profits will be greater. There's going to be a steeper slope for the more skilled farmers. So we can estimate this with the panel data. So this is looking at the last 2 years of the 3-year panel. Again, it's fixed effects farmer. So all of the identification comes from the changes in H5B use over time for that farmer. They're again predicted by the initial state variables of these farmers. And what you can see is, first, that there's evidence of learning, that the contribution of high yielding varieties is greater, the greater is experience. But secondly, the contribution in the third period from an additional year of experience, okay, is less than the contribution in the second year. So there's diminishing returns to experience. Fine. Okay. We also see, just as we saw in the initial specification, that primary schooled farmers get more from high yielding varieties. Okay. But this specification is not complete, because the full specification should take into account that the contribution of schooling will depend on, if there's learning, the amount of prior HYV use. So when we have the triple interaction in the term, we get a very clear answer, which is that if there's no prior experience, the contribution of primary schooling to the contribution of high yielding varieties to profits is 0. Okay? That the advantage seems to be that the more educated farmers, in this case primary schooled farmers, are getting more productivity the greater their experience. So it's a learning effect over time, that the schooling is enhancing the ability of farmers to learn from their own use of the high yielding varieties. We also see this, for example, from loom workers in the United States in the mid 19th century. So the loom workers who have only 1 month of experience have much lower productivity than those who have more than a year of experience. And what we can see is that over time, the loom worker productivity increases at a decreasing rate. So they're learning about how to best use these looms in these factories. So it's not just an agricultural phenomenon. Any kind of new technology that's complex requires figuring out how to best use it. All right. Now, these are conditional profit functions. They condition on the actual use of high-yielding varieties. What about the unconditional profit function? What's missing in the conditional one is the actual decision to use the high-yielding varieties at all. Okay. So the total effect of schooling on profits in this environment in which there's new technologies shouldn't condition on the use of the technologies. It should be unconditional. Okay. So it tells us what we want to know is how the contribution of schooling to profits varies by the level of technology, theta. Okay. So this is a different use of theta, unfortunately, because it's a different study. So theta here is the technology. So the challenge then is, how do we estimate the technology? And to do that, we're going to exploit the characteristics of the Green Revolution, that there's area-specific variation in productivity growth after the Green Revolution. That's going to be exogenous depending on soil conditions. And so after the onset of the technology, it's going to grow differentially in different areas. All right, so let's specify a profit function, parameterize a profit function. To keep things simple, we'll make it linear. Okay, so it says that profits is going to be a function of the initial assets of the farmer, the schooling of the farmer, and prices of inputs of labor and say fertilizer, plus a farmer fixed effect. After the Green Revolution starts, then we characterize the Green Revolution as changing the technology, which means that the parameters of the profit function are going to change. So let's specify that each of the parameters of the profit function, assets, schooling, and the prices, change as a function of the technology. Okay, and they change by an amount alpha. The change for each of the specific prices or assets can be different, okay, but the theta, of course, is the same. So theta is the area-specific level of technology, which is assumed to be 0 before the Green Revolution. And alpha tells us the differential contribution of a fixed or variable input price to profits by theta. Okay. So alpha S is what we're interested in here. That's the extent to which an increase in technology increases the total return to schooling. But of course, the problem is that theta, which is sort of the residual for this profit function, can vary for lots of reasons, including that the soil and water conditions of the environment in which the farmer is working are different. So it may not be capturing technical change at all. If we were to estimate this equation, it just may tell us, if these are area-specific dummies for the thetas, that areas that have richer soil have higher profits. Okay. So what we're going to do is we're going to difference these two equations for the same farmer, taking advantage that we have information on the farmer's profits and input prices and assets in 1971, the last year of the 3-year panel, and in 1982 for exactly the same farmer. So when we difference, we get a nonlinear equation where now the intercepts, which will be dummied out, they could be dummied at the village level or the district level, capture the change in technology that are area specific, village or district specific. Okay, and we can identify, even they're linear in parameters, we can actually identify from this equation the alphas and the betas. Okay. So it identifies the pre-Green Revolution return to schooling, that is what we're interested in, and also how the returns to schooling changed after the onset of the Green Revolution, and it also identifies the area-specific taus, the changes in technology. And this identification is coming, just to highlight this, from the assumption that the thetas vary across areas after the Green Revolution, but the effects of the thetas on the different inputs are the same across areas. It doesn't seem like that strong an assumption, but nevertheless, it's important for identification. So what do we get? So these are the estimates of the betas and the alphas for the different assets and prices. So for example, for irrigation assets, not surprisingly, the alpha is significant and positive. That it tells us that the returns in terms of profitability to irrigation assets rose after the Green Revolution. For our purposes, though, the estimates also tell us that the returns to primary schooling also significantly increased over time. So what does this mean for profitability of farmers at different schooling levels in different areas? Well, we can use these structural parameters to calculate that. So for example, in the state of Kerala, we get a very low tau. The actual technological change in Kerala, the frontier technological change in Kerala was pretty low because the suitability of the high yielding varieties of corn and wheat and rice and sorghum was not very high in that state. And what we find is that the primary school farmers had about 10% higher profits than the illiterate farmers in the states where there's a low tau. In intermediate states like Karnataka, the differential in profits between primary school farmers and illiterate farmers was about 17%. But in the Punjab, where the high yielding varieties were most suitable and had the highest productivity, the differential between the primary school farmers and the illiterate farmers was 40%. Okay? So this is showing within the state of India, the productivity of schooling varies enormously depending on the state of technologies in those areas. Okay. There's evidence that there's learning from others in agriculture from the study of the returns to experience. It was also shown that profits rose faster the more there was adoption of high yielding varieties from neighbors, which in this case was defined as farmers in the same village. And the trajectory of profits with neighbors' experience, conditional on own experience, exhibited the same diminishing returns. So it looked like there was also learning from others. In Kaivan Munshi's study, using the same data set, he found that there was more learning among wheat than rice farmers. And that made sense because the information from wheat farming is much more generalizable than rice farming. Okay. And there's sunflower seed adoption study that showed that the more schooled were adopting the new sunflower seeds that were novel for the environment that was looked at. And also some indirect evidence of learning, which is a consequence of these models, which is that there's strategic behavior. If you learn from neighbors, then you have a return to actually free riding. And so you're going to actually withhold adoption, waiting to see how the others do. All right. So our next question is whether, in fact, schooling investment responds to changes in returns. And we're going to look at two environments. The first is, again, looking at the Green Revolution and asking whether in areas where there was an increase in the productivity associated with the new seeds, and which the data suggests increase the returns to schooling, do we actually see that enrollments increase? And then we'll look at, so that's the rural areas, then we'll look at the effects of reforms in India that opened up the economy, looking at a population in Mumbai where the returns to knowing English increased enormously, and we'll see to what extent that affected enrollments in English medium versus local language schools. Okay. So let's look at the Green Revolution. So we have estimates of the taus, which are the residuals from the profit function that control for assets, changes in prices, changes in weather, and even the returns to assets. So those are our estimates of the technological change. But of course, as residuals, they contain a lot of noise, they contain measurement error, among other things. And if we wanted to use them as a regressor to look at whether they in fact affected behavior, we would have biases. In particular, if it's classic measurement error, which is not obvious, the bias would be to zero. So what's done instead is to use the residuals as an instrument to predict yields. So to use information on yields by area or changes in yields by area, instrument them with the tau. So that eliminates the measurement error. And so what then we can ask is, did the growth in yields or the speed in growth in yields affect changes in school enrollments? Okay. So if we graph the change in crop productivity over time with the change in school enrollment that occurred between the 1971 round of the data and the 1982 round of the data in the same districts, we see there is a positive slope. Okay. But we can, of course, do better than that. We need to control for variables. So let's look at that. So again, we're going to have a farmer fixed effect estimates of predicted yields per hectare and yield growth. So we have the change in yields between 71 and 82 and the change in yields between 68 and 71. So we can look at both the level effect of technology and the change of technology on schooling. The dependent variable is enrollment rates of children aged 5 to 14. Okay, so we observe enrollment rates in these farm households and non-farm households in 1982 and in 1971. And for the same farm households, we're looking at how in this case, the district in which the farmer household was residing, there was a response of schooling investment measured by these enrollment rates to the changes in yields and the change in the yields. Okay, and what you see is very clearly that where the yields were higher is predicted by these technological change residuals, and where there was accelerated yield growth, there was an significant increase in school enrollment rates. But we can do more than that. We understand what is the basis for the higher return to schooling from the technology, that farmers were better able to learn to allocate resource inputs better on the farms. Okay, so the farmers are making decisions about how to use inputs. But there's another class of workers in agriculture who do not make decisions. These are our harvest and fertilizer workers, the wage workers. They're just given direction on what to do. They make no decisions at all. There's nothing for them to learn. They take instruction. This is, of course, a little bit of exaggeration, but basically they're directed by the farmers on what to do. Okay? So if learning is important, what we would expect is that the wage workers, the landless workers, that are not farmers, but rather work for farmers, would not respond to the new technologies at all. So when we break up the sample into non-farm and farm households and interact, whether it's a non-farm household with the change in yield growth, what we see is for the yield growth variable, that there's a negative coefficient on the interaction. Then what this tells us is that the response of schooling by the non-farm households to the change in technology was far less, significantly less, than it was for the farm houses. In fact, the total effect, which is the sum of these two coefficients, is itself statistically significant negative, which tells us that when there was an increase in technology, there was an increase in the school enrollments among farm households, but actually a decrease in the enrollment among non-farm households. Now, wages went up. This controls for wages. Okay. Why is that? Well, what was going on is that the technology was actually a technology that used labor. It used all inputs. It wasn't a labor-saving technology. So the demand for labor went up in the farm households. Meanwhile, the farm households were sending their children to school, so the demand for child labor actually increased in the economy, which then meant that the opportunity cost of schooling went up for the non-farm households. Okay? And indeed, the opportunity cost of schooling matters. We can see that in this equation, we have the male wage rate. And in fact, the higher is the wage rate, the lower are school enrollment rates. Okay, so this expanded the differences in schooling across farm and non-farm households. Okay. We can actually look, now, this was data from 1982 and 1971, right? It's this ancient history, no longer relevant to what's going on. Well, we could use a newer data from ICRISAT, the International Crop Research in the Semi-Arid Tropics, their village level studies, which have been used to generate a lot of important studies in economics. We can look at the latest rounds of those data and look at the relationship between the maximum schooling of the farmers, the maximum meaning we take the maximum level of schooling of any male in the household, because it's in India, it's the males that are making farming decisions. And what we see is, these are standard errors now, that indeed given total land owned and given controls for a massive number of soil qualities, and given fixed effects for the village, so that controls for the sort of conditions in the environment, that a farmer with secondary schooling gets 35% more output for the same size of land, the same share of irrigated land, and the same 24 characteristics of soil quality. And in terms of profits, there's also about a 15% increase. These are in absolute numbers, but they're about 15% higher for secondary of schooled farmers. There's very little effect of primary schooling. So there is a change from the 1980s to the second decade of the 21st century. And now secondary schooling seems to be more important. Okay. Now, a big caveat here, right? It could very well be that this is reverse causation, that farmers that are richer are just been able to invest more in secondary schooling. Okay. But what's important here is that we can observe the same farmer engaged in agriculture also engaged as a wage worker. Now, not all of the farmers are wage workers. We have to take into account that there's selectivity. So what we do is we look at the determinants of the probability that a farmer among those with the maximum schooling, so there's 4,100 males from these farm households, because in some of these farm households, there may be 2 males with the maximum schooling. Okay. This tells us that, in fact, among those, given again the amount of land that they're cultivating and their age and the irrigated amount of land, the more schooled of these are much less likely to work on the wage labor market. But taking into account that selectivity, controlling for the selectivity using the control function approach, which seems well identified here by the amount of land that they own, we see that there's zero evidence that these same farmers who exhibit a strong correlation between their secondary schooling and profits, there's no relationship for them when they go into the wage labor market in terms of earnings. So that's consistent with what we saw for the piece rate wage workers. And in almost every data set that I've ever looked at, when you look at wage workers in agriculture, you do not see any evidence that there's a benefit to higher schooling. So we see this differential of the returns to schooling by the type of work that's done even in this later period. Okay. We now have some time to look at the circumstances in Mumbai. It's called Bombay here because historically, this slide is describing what was true in Bombay before the reforms in India. Okay, so Mumbai was an industrial city. Blue collar jobs were very important there. People were working in the fabric, producing fabric in mills. Okay, and India underwent a major reform for the economy, which opened up the economy. And in doing that, it made trade and financial sectors much more important than they had been in the prior periods. And one consequence of that openness was that as now a major player internationally in these sectors, English became a valued skill much more than before in this new economy. And in Mumbai, agents needed to make a choice between going to English medium schools where the instruction was all in English, starting from the very first grade, or local language schools. And the key difference between these schools, besides the medium of instruction, was that the public schools were free sorry, yes, and the public and the private schools had tuition. So the issue for us is, can we show that the returns to English actually increased in terms of earnings? And do we see a shift in enrollment rates from the local language schools as a consequence to the English medium schools? Okay. Now, if you go to an English medium school, it opens up your employability to occupations where English is valued. And it also allows you to continue your education because most of the instruction medium in the universities in India was, in fact, in English. Right. Now, we have data, which I'll describe in a minute, from Mumbai, which shows us that, in fact, between the 1980s, pre-reform, and the 1980s, for the same individuals, those who had gone to English medium schools exhibited a much higher returns. Okay, so if we look at men, if we look at the 1980s, this is from log earnings equations, which have years of schooling on the right-hand side and just a dummy variable for whether or not the person went to an English medium school. And these then are just graphing the rates of return. So the rate of return to years of schooling was about 10%. And the rate of return to going to an English medium school, that is the earnings premium, was about 15%. So it always had been tied. But when we look in the 1990s, after the reform, the premium, there's no change in the returns to years of schooling, but there's a big change in the premium from going to an English medium school. So it goes from about 15% to about 22%. Okay. And that's for men. And for women, there was also an enormous increase in the returns to going to an English medium school. All right, now, if we look pre-reform at the composition of the schools by caste, they look very different. So the rate of English medium schooling for the upper caste, who are also the wealthiest families in Mumbai, is 15 times higher than in the lower caste. And this is true for both boys and girls. And I'll show you this in a graph in a second. So what we want to know is, did the composition by caste change in the English medium schools? Okay. And in particular, we want to compare the changes in enrollment rates across the local language and English medium schools by these castes. This is going to tell us something about what the key barriers are. So what we would think of when we look at lower caste enrollment, lower castes have lower income by a lot. They face credit constraints, that we would be pessimistic about lower caste shifts in enrollment to the expensive private schools. But there's another issue, which is that parents of lower caste students themselves were much less likely to know English because they themselves didn't go to English medium schools, which means that they cannot be of much help with the homework of their students who do attend English medium schools. So these are two reasons to think that we would not expect a convergence of enrollment rates across the lower and upper castes. So what do we see? This is just saying that basically, if there aren't these barriers, we should see convergence. All right, so what do we see? So first, let's look at the female students. So we have as our control what was happening in the high caste, and we see that they're shifting to English medium schools over time. So there's a trend, okay? For the lower caste girls, there's not much change in enrollment in the English medium schools prior to the change in the policies of India or to the reforms. But by the end of the 90s, there was a substantial shift of enrollment in English medium schools. So the composition has changed a lot in English medium schools. And what we see is evidence of convergence, that the gap has shrunk by a lot. What about for the boys? For the boys, well, we see again that among the high caste, there's a trend upward. It seems to have increased more in the late 1990s after the reforms. And that's also true for the boys in the lower caste, but convergence is much less compared to the girls. Okay, so if we regard this, what happened for the high caste as our control, we can see that there should have been a much greater increase for the lower caste, as we saw for the girls relatively. Okay, so the puzzle is why the boys' convergence seems to be inhibited relative to the girls. Okay. Now, one question, of course, is whether this increase in the returns to English medium schools is just an artifact of the fact that the English medium schools are better schools. And so the quality of schools was showing up more after the reforms. Okay. So we're going to look at that as well. So the issue is whether this shift in enrollment reflects an increase in demand for English or just for better schools, and why we have this differential by boys and girls. And so in this study, this is by myself and Kaiwa and Munshi, we looked specifically at the role of caste networks. Okay. And the castes, which are alive and well in Mumbai, specialize in occupations, as I'll show you. The lower caste predominantly in blue-collar jobs, and the upper caste predominantly in professional occupations, white-collar occupations. Okay. This specialization characterizes men, but not women. Okay. And the third factor is that castes provide particular services, namely job referrals. And the job referrals are much more important for blue-collar jobs than they are for the white-collar jobs. Okay, so these are the roles of the castes in Mumbai. Okay. So in this article, there's a model of caste choices within castes of choosing English medium schools versus local language schools. There's tests of the model, and then there's an examination of alternative networks. So this is the model. I won't have much time to explain it, but it basically highlights that there are two types of jobs. Okay, and the key difference between the two types of jobs is that in the blue-collar jobs, payment is based on the expected productivity of workers. Individual productivity cannot be discerned, and the higher the fraction of the caste in the occupation, the higher are wages. And that's going to be shown in equilibrium to be true, because what it means is if there's less participation of caste members in that occupation, there's negative selectivity exhibited, so that on average, the ability of the workers are going to be lower than would be the case if all of the workers were represented in that occupation. In the professional occupations, however, there's returns to individual ability. That's what differentiates them. Okay. English is necessary, okay, and there's heterogeneity in ability. And the consequence of that from the model is that it can be shown that there's multiple equilibria, okay, where the equilibria are everybody in the caste is actually choosing to go to local language schools, or only the high ability types are going to English medium schools, or in fact, it's only the low ability types, if there's three types, that are at all go to the local language schools. When there's a change in the returns to schooling, what you see is a shift from each equilibrium to the next equilibrium. So from equilibrium 1, where everyone is going to a local language school, when there's an increase in the returns to English, what you see is a shift only of the high ability types. Okay, so this has implications that students in English medium schools will always have higher ability, that average ability will decline in the Marathi schools, the local language schools, as the returns to English increase, and that will increase more in the Jatis that are concentrated in the blue-collar jobs. Okay, so what about the inhibition of movement? Well, it turns out that because of the network externalities, if the Jati or the caste wants to maximize the average wage, it will turn out that for lower levels of the returns to schooling, allowing the higher ability persons to escape from the blue collar jobs to those jobs that reward their high skill will mean that the average wage for everyone in the jobby will be lower. And therefore, the jobby has an incentive to reduce that outflow. Okay? So you get this restriction. Now, when the returns to English go up sufficiently, then that restriction becomes less than optimal. But in fact, for some levels of the returns to schooling, this restriction, because of the network externality, is actually efficient. So in the data, which is based on 4,700 student records from students residing in 29 schools in a big neighborhood in Mumbai, where we get this information about the returns to schooling, we see that in fact, two things. Based on schools, that indeed it's true that the students do much better in the English medium schools than the Marathi medium schools, significantly better on test scores. But when we look at school characteristics, and this is the full set of characteristics that were obtained, there's no difference in any individual characteristics or the set of characteristics across the English medium and the Marathi medium schools. Okay. And we're able to show that there's these differences in the importance of referrals, and that indeed there's concentration of the lower and middle class in organized blue collar jobs compared to professional jobs. That's occurred for 2 generations. And the bottom line of this, the study is to show that in fact, the inhibition of movement is only for the boys who are in the caste network and not for the girls. And that there was a decline in the measured ability of the parents, the schooling of the parents for those students in the local language schools over time as the returns to English went up, just as the model suggested. And the end result was that in fact, there was a breakdown in the caste system itself. So let me stop there. The point being that in this urban environment, there was a substantial response to changes in the returns, just as there was in the rural environment. And let me now take the questions.
Great. Thanks everyone for posing your questions in the Q&A box. We're just going to do a selection of 3 to start off with and see if we have time for more after that. So Mark, the first question is from Risha from India, and she wants to know the reasons why India and Pakistan both are exceptions to the fact that years of schooling for women is greater than that of men in other countries. So any insights you can provide on that? The second question is from George Yang. How does a country increase skill prices? And have you seen any change in skill prices across time after your 2010 study? And the third question is a bit of a long one from Seong Yoon Kim. Doesn't the use of the immigrant survey bias the estimators of the year of schooling, given that the immigrant may choose different jobs once they move to the US? They may have been making a certain amount at a certain job, but they chose to move to the US for various reasons and taking a lower human capital job for a higher wage.
Okay, good. So the first question is, I can't answer. That is to say, there's a puzzle for you. And understanding the reasons why there's more schooling for women compared to men in general, but there are exceptions, is something that needs research. In tomorrow's lecture, we're going to look at what you would examine in answering the question of the differential enrollments and attainment of schooling by boys and girls. That will give us a clue as to what to look to when we're comparing different countries of the world. But right now, we can't answer the question of why there are these two outliers. We can for sure say it isn't religion, because they're of different religion, and there are countries with at least the same religion as Pakistan, where we do not see that exception. How to change the skill prices is the basic question of development. If we knew how to do that, we could solve the development problem. What this lecture is showing you, that's where the problem is. And the answer to it is not necessarily just increasing schooling. So we know what not to do. as a main focus, but we're not exactly sure what to do. Obviously, enhancing the degree to which there's technical change is going to change the return to schooling. And we see that, for example, in the Mumbai case and in the Indian case, there were changes in the skill prices due to a change in technology. And in the Mumbai case, due to a change in the structure and composition of the types of jobs that were more valued. Okay, so we know it can happen. We know it's going to be a function of the big things that are occurring in the economy, not from simple little interventions, but we need to know more in order to do that. For China, for example, the rates of return to schooling and the productivity of schooling clearly rose enormously. And by the way, they rose more for women than they did for men, which we'll also explain tomorrow. The last question about the immigrants. So yes, the immigrants, the sample of immigrants is obviously a selective sample of workers around the world. But what jobs they took in the US is irrelevant. This was looking at the jobs they had in their home country. And so it just looks at their home country wages and compares workers who happen to come to the US from, say, Pakistan to workers that happen to come to the US from Mexico. So it's the environment of Mexico and of Pakistan that mattered for the returns that they had to schooling in their home country. Now, it's not a representative sample of all workers in that home country. And we know in general that the workers who migrate tend to be unobservably more skilled. So these people are more likely to have higher returns even in their home country than the average worker in the home country. So if anything, the estimates of the returns to schooling might be biased upward, but it's not obviously true that the selectivity is very different across the countries, but it's something that might be examined. But it has nothing to do with what jobs they take in the US.
Okay, let's do two more questions. The first one from Tigist Ketema. For agricultural productivity, are we assuming that farmers have similar experience and knowledge of the local environment? Most farmers, especially in developing countries, don't go to formal schooling, rather acquire knowledge through experience. And the second question, are the skill prices or wages measured in real terms?
Okay, just two?
Yes.
Okay, all right. So the first one, yes, right. A major part of the lecture was spent on showing that there are high returns to learning by experience that has nothing to do with schooling, that farmers learn about their environment over time. And what it showed was that the returns to that learning were higher for the more schools, that the role of schooling was to, in fact, enhance the ability of farmers to learn about the environment that they're in. And so absolutely, farmers without schooling still learn. It's just that farmers with schooling learn at a faster rate. The skill prices, yes, the skill prices are all PPP adjusted. So for purchasing power parity, to take into account the differences in the cost of living across the country. So very much they are real in that sense and comparable. They're one point in time, so we don't have to worry about inflation. It was all taken in a given single year.
So we're reaching 1 minute till the end of the lecture. Mark, do you want to say any last remarks before?
No more questions? Is that what?
There's a lot of other questions, but I just don't think we have time.
Okay, so we can have more for tomorrow.
Yeah.
Yeah, so the point I want to make is that if we're looking at differences in income per capita across countries, the differences are not due to differences in schooling, but much more due to differences in the productivity of schooling and the skill prices of schooling, and understanding what determines those skill prices is what we need to understand in terms of that. And so understanding why enrollments in schooling are low is, in fact, a major reason that the productivity of schooling may be low. And what we've seen evidence of is that when the productivity of schooling goes up, there is a response of households to investing in schooling. But tomorrow we're going to look at It isn't so simple. There are real barriers to schooling enrollments that are other than low productivity. And we're going to focus on a number of those, including the opportunity cost of schooling, large family sizes, and health. And in particular, we'll look at interventions that try to ameliorate those barriers to schooling. Okay, so thank you, and hopefully we'll see you all tomorrow at the same time.